So welcome to Mentor Dada. Today I am going to discuss about tectonic part from your CSIR NET. And today I have assembled some questions from your previous year's question papers, mainly from 2014 to 2019. And the rest of the part will be uploaded later. So now look at the first questions. The first question is, which of the following is an example of hotspot within a continental plate? Number one option is Bermuda, second one Yellowstone, fourth Azore, and four Easter. So let's think about one by one. Okay. So we all know about Bermuda Triangle, right? So Bermuda is situated in the eastern side of the North American continental part, right? So it is situated on the North Atlantic Ocean. Okay, so it is situated on the North Atlantic Ocean. So Bermuda is situated on North Atlantic Ocean, and this is situated at the eastern part America, mainly North America. Okay, North America. And second one is Yellowstone. So Yellowstone is continental, is situated on the continental plate. And Yellowstone National Park, you all have know about it, and Yellowstone hotspot is situated around Yellowstone National Park, and this is situated on the North American plate. Okay, so this is situated on North American plate, and this is situated on North America. Okay, so this is your correct option, Yellowstone. Azore, what is Azore? Azore is situated exactly on the triple junction between Arabian plate, African plate, and Somali plate. So Azore is a hotspot which is situated at the triple junction, and along this triple junction, one arm of this triple junction between Somali plate and African plate is known as East African Reef system. Okay, and this is not at all situated on the continental part, rather it is situated on the Gulf of Aden, or you can consider it that it is situated at the junctions between Red Sea and Gulf of Aden. Okay, so Azore will not be a correct answer for this question. And next is Easter. So Easter is situated in the Pacific Ocean. Easter is situated on the Pacific Ocean, and this is situated towards the west of South America. And very interestingly, this is situated between Nazca plate and Pacific plate. Okay, and the plate boundary between this Nazca plate and Pacific plate is a mid-oceanic ridge. Okay, this is a mid-oceanic ridge, or rather this is called as East Pacific Rise. So as Easter is situated in the Pacific, Ocean, so this will also not be your correct answer. Now come to the next questions. The magnitude of earthquake increases with decrease in focal length or epicentral distance, or increase with increase in focal depth and decrease with decrease in epicentral distance. Option 4, increases with decrease in focal depth and increase with increase in epicentral distance. Option 4 is independent of the epicentral distance and focal depth. So magnitude of an earthquake. What is magnitude? Magnitude of an earthquake is the measure of the released energy. Okay, so intensity of an earthquake and magnitude of an earthquake are completely different. Intensity only determines the relative destructiveness. Okay, but the magnitude is the measurements of the emitted energy during the earthquake. So in case of any earthquake, released energy is always a fixed value, so it does not depend on epicentral distance, and it also does not depends on the focal depth. So option 4 will be your correct answer. Next question is, which one of the following is the principal source of the arc magmatism? So arc magmatism is related to subduction zone. In subduction zone, one plate is subducted beneath the other, so one is overriding plate and another is subducted plate, right? So in case of subducted plate, what happens? Subducted plate releases its water and other volatile materials to its above situating mantle part. Okay, so at this portion of the asthenosphere gains some amount of volatile material. As a result, the melting temperature of this asthenosphere decreases, and this produce this melting, and this melting is called flux melting. Okay, so flux melting of this part of asthenosphere will produce magma. Okay, so mantle wedge, because asthenospheric, this is the part of asthenospheric mantle which is suffering melting, so option number 2 will be your correct answer. Option number 4 is D double prime layer is the source of mantle plume, and this is situated at the core mantle boundary. Okay, subducted sediment will also not be your answer, because subducted sediments not easily carried at this depth, and subducted oceanic crust is not melted. Subducted subducted oceanic crust actually dehydrates, okay, and as a result it releases some amount of water or other volatile materials to its overlying mantle wedge. As a result, the melting temperature of this mantle wedge decreases and it promotes melting. Okay, so now move to question number 4. Which of the following tectonic features demarcates the boundary between the higher Himalayan crystalline and Tethys Himalaya? Option 1 is main central zone. Option 2, main boundary thrust. Option 3, Indus Sangpo-Sucha zone. Option 4, southern Tibetan detachment zone. So first of all, try to understand or try to remember each of the thrust zone in the Himalayan region from south to north. If you move from south to north, first of all there will be your sub-Himalaya, right? So sub-Himalaya, then sub-Himalaya, then lesser Himalaya, then will be your greater Himalaya, then Tethys Himalaya, okay, Tethys Himalaya, okay. So sub-Himalaya and lower Himalaya or lesser Himalaya is separated by main boundary thrust, and lower Himalaya and higher Himalaya or greater Himalaya is separated by higher Himalaya is not the right term, it is greater Himalaya crystalline complex. So lesser Himalaya and greater Himalaya crystalline complex will be separated by MCT, and greater Himalaya crystalline complex and Tethyan Himalaya sequence TH, which I have marked as TH, is separated by South Tibetan detachment, STD, South Tibetan detachment. Okay, so here number 4 is your correct answer. So this is northern part and this is the southern part. So from south to north, first you will observe sub-Himalaya sequence, then main boundary thrust, then lesser Himalaya sequence, then main central thrust, then greater Himalayan crystalline, then South Tibet detachment, and then Tethys Himalaya sequence. Okay, so this will be the sequences from south to north. Now move to the next question. Question number 5. Which of the following process is not related to plate tectonic? So option 1 is subduction. Subductions means one plate is subducting beneath the other. So of course this is related. The question is which of the following is not related. Number 2 is mountain building. Mountain building process occurs where continent collided with each other. Two continent collides with each other. Number 3, rise of mantle plume. Mantle plume comes from the D double prime layer, which is the core mantle boundary, right? So this is not at all related to any plate tectonics. Okay. Number 4 is sea floor spreading. Sea floor spreading is related to mid-oceanic ridge, where sea floor is creating. So your answer will be option number 3. Number 6, in a homogeneous isotropic medium with a free surface. Number one, only raylight waves can exist, only love wave can exist, both raylight wave and love wave can exist, neither raylight waves nor love waves can exist. Okay, and the correct answer is only raylight wave can exist in homogeneous isotropic medium with a free surface. So answer 1 will be your correct option. Question number 7. Mid-oceanic spreading ridges are characterized by deep slip faults, normal faults, strike slip fault, thrust fault. We all know that mid-ocean spreading ridges are extensional plate boundaries. So if you consider a extensional regime, you will find normal fault system where horst and graben structures are very much common. So your answer will be option number 2. Okay, thrust faults, these are very common in collisional plate boundary or convergent plate boundary, right? So convergent plate boundary, right? Normal fault is in divergent plate boundary, or you can say it as extensional plate boundary, extensional plate boundary. Okay, next, look, why deep slip fault will not be your correct answer. A deep slip fault can be a normal fault, can be a reverse fault, so it does not at all signifying any specific type of plate boundary. Okay, next one is and if you ask me why option number 3 will be correct, look, this is a strike slip faults. Okay, this has not been written as a transform plate boundary or transform fault. Okay, so this has been written as strike slip fault. Okay, so that is why it will not be your correct answer. Okay, and strike slip fault, deep slip faults are completely two different categories in terms of pitch of net slip. Deep slip fault is one where pitch of net slip is 90 degree, and strike slip fault is one where pitch of net slip will be 0 degree. So these two cannot be possible. Okay, next, density contrast is maximum across the crust mantle boundary, mantle outer core boundary, outer core inner core boundary, upper crust lower crust boundary. So your correct answer will be core mantle boundary. So it means mantle and outer core boundary, density contrast is always maximum. Okay, next, Earth's reference spheroid. Earth's reference spheroid. So try to understand this thing. Suppose these are the lowlands and these are the highlands. Okay, and this is your mountain, this is your ocean. So spheroidal earth, if you consider the spheroidal earth, this is somehow like this. Okay, this is spheroid. And if you consider the geoid, so your question is Earth's reference spheroid. Earth's reference spheroids coincides with the geoid in the oceanic region, coincides with the geoid in the land region. Option number 3 is below the geoid in the ocean region, and it is above the geoid in the ocean region. So how geoid is? Geoid is something like this. Okay, this is geoid. So in oceanic region, spheroid is situated above the geoid. Okay, in the oceanic region. And in case of mountain region, in case of elevated region, spheroid is situated below the geoid. So option number 4 will be your correct answer. Now question number 10 is, interpret earthquake predominantly occurs in the depth range of 0 to 40, 40 to 100, 100 to 300 kilometer, 300 to 700 kilometer. Look, this is an interpret earthquake, so this will never be intermediate depth, or even it will never be a shallow depth. It will never be a deep focus earthquake. So interpret earthquakes are always very shallow focus earthquake. So option number 1 will be your correct answer. Okay, and we all know that shallow focus earthquakes are most frequent, and most of the earthquake occurs along the convergent plate boundaries, and mainly in the Pacific Ring of Fire. And the deep focus earthquakes are very rare. So the 300 to 700 kilometer focal depth of an earthquake is very, very rare. Okay, so this is not occurs very frequently. Okay, now come to question number 11. So you have to pick the correct match. So plate boundaries, processes and examples are there. So let's see. So in option number in plate boundary, the divergent plate boundary is there. So divergent plate boundary is such boundaries where two plates are moving away from each other. So seafloor spreading, continental rifting took place, right? So your A will be matches with F, and example of such thing is East African Rift Valley. And now convergent plate boundary means two plates are colliding with each other, so subduction and collisions took place, right? And as a result, what we could see, either mountain building processes or island arc or volcanic arc formation took place along these boundaries. So it matches with this one. So let's see, AFH is your correct match, AFH. So and BDI, so option number 4 will be correct. Okay, now number 12. Plate, as in the theory of plate tectonics, is a fragment of oceanic crust, fragment of continental crust, part of oceanic and part of continental crust, fragments of lithosphere. Okay, look, a single plate is not only contain just a part of ocean, just a part of continent. Okay, and plate does not deal with such terminologies, whether this is continental or oceanic. So plate means the fragments of lithosphere. Okay, plate means the fragments of lithosphere. So some plate can be entirely of oceanic crust, can be of entirely continental crust, but when we are considering plate, it does not give any, it does not signify any importance regarding the oceanic part or continental part. It mainly the fragment of lithosphere. So option number 4 will be your correct answer. Okay, now 13, option number now MCQ number 13, the velocity of tsunami wave is dependent on. So first of all, let's memorize the velocity of tsunami wave. Velocity of tsunami wave is equals to root over GD. D means depth of sea floor. Okay, D means depth of ocean. Okay, so now read the options. Option number 1 is the focal depth and the epicenter distance from the shore. The focal depth but not the epicenter distance from the shore. The epicenter distance from the shore but not the focal depth. Number 4 is neither the epicentral distance nor the focal depth. So as per the equation, it does not depend on epicenter distance nor on the focal depth. Okay, it only depends on the depth of ocean. So option number 4 will be your correct answer. Now move to question number 14. For paramagnetic material, susceptibility is. Paramagnetic material susceptibility is, look, when you are considering paramagnetic materials, there may be some very weak magnetism, but still the magnetic susceptibility will always be there, right? So it will always be positive, and we all know when you hit a paramagnetic material, it will lose its magnetic property, so susceptibility will decrease, right? So option number 2 will be your correct answer. Let's move to question number 15. Which of the following tectonic feature is a consequence of continent-continent collision? Look, first try to understand or try to visualize what are the characteristic feature of a continent-continent collision boundary. So in continent-continent collision boundary, you will always observe some orogenic movements, right? So orogenesis will be there. So huge mountain belt formations will be there, and that mountain belt will be characterized by fold mountains and fold thrust belts, right? So here is 4 options. One is Mariana Trench. Look, Mariana Trench is a collisional boundary between ocean and ocean. So Mariana Trench is one of the deepest trench on the earth, right? And this is the most deepest point of the crust. And option number 2 is mid-Atlantic ridge. This is a mid-Atlantic ridge, or we all say mid-oceanic ridge, where 2 plates are going away from each other. African plate and American plates are moving away from each other. So this is a divergent type of plate boundary. And if you consider Andes Mountain, so Andes Mountain is the collision between a continent and a oceanic part. Okay, and Andes Mountain is forming at the collisional boundary between American plate and the Nazca plate. So Andes Mountain will not be your answer. And option number 4 is Himalaya, and this is the collision between Indian plate and Eurasian plate, and this is a continent-continent collision. Okay, so option number 4 will be your correct answer. Okay, why Himalaya is very important? Here you will get the thickest crust, around 79 kilometer thickness of the crust you can observe here. Okay, and this is still a very active mountain zone, and Himalaya is continuously rising. Okay, and it also has been predicted that within 30 million years this rising will be completely stopped, and then Himalaya will suffer erosional process dominantly. Okay, so for these questions option number 4 will be your answer.